Sorry. Now I'm audible. Please confirm it. Okay. Whether you were able to hear the description related to the undercuts, or I have to repeat it. Okay. Okay. I will repeat it. Okay. Now these are the undercuts. Shubham, whether my voice is audible now? Please confirm it so that I will repeat all the part. Shubham Kakade. Okay, okay, and then I will repeat this part. Okay, sorry for that. I think some problem is there in my headphones. I have corrected it. Now we will. I will repeat this part. This is the undercut design of the undercuts in the plastic parts. So, what is the meaning of undercut? Undercut is an projection on the molded part, okay, which makes ejection of the that molded part from the mold. Suppose we are using two plate mold, then almost this ejection of that part from that mold becomes impossible due to this undercut. Okay, now as far as the types of these undercuts are concerned, four types of undercuts are there: internal undercut, external undercut, circular undercut, and undercut on the side wall. Okay, these four types are there. Now, before discussing this detail, commonly all these undercuts are manufactured with the help of some cutting tools, or with the help of core pins. Okay, with the help of core pin or different types of the cutting tools are used to make these different types of the undercuts. Okay, now I will explain that with the help of next slide. Before that, this point is very important. As far as possible, you have to try that these undercuts should be avoided. Okay, undercut should be avoided. Whenever undercut is there, it will increase the cost of the mold. Okay, it will increase the cost of the mold. And due to this, again, the second effect is that due to the presence of these undercuts, it will increase the lead time or cycle time of the molding process. Lead time or cycle time of the molding process increases, and which results in the increase of the price of the final product. Okay, so this is the effect of the undercut. To avoid these effects as far as possible, these different kinds of the undercut should be avoided. Okay, uh, means it will increase the cost of the mold, and the second effect, it will increase the cycle time or lead time of the process, hence increases the cost of the manufactured or molded part. So that's why these different kinds of the undercut should be avoided. And then these are the different types of the undercuts. Same diagrams are there. These diagrams, I think these are not clearly visible here. That's why I have added this separate slide here. In the first diagram here, you can see this cursor. This is internal undercut. This is your molded part. And these are internal undercuts. This is the molded part. This is the molded part, and this is the external undercut. And this is the molded part. This is your mold, and this is undercut on the side wall undercut. Okay, and this is the circular undercut. Okay, these are different types of the undercuts. Due to presence of this undercut, what will happen when you are ejecting the component or molded part by opening the mold? Then due to this undercuts, you will be not able to remove it from the mold cavity. Okay, then how these different undercuts uh, are made? Here, this internal undercut. Okay, this is the internal undercut. Now, sometimes these undercuts are required in the molded part. That's why you have to manufacture it or you have to make it. Now, for this internal undercut is made by using the tool. Okay, that tool is termed as the injector wedge or elaborate tool. Okay, elaborate tool or injector wedge. With the help of that, these internal undercuts are manufactured. Okay, please draw this diagram. You have to mention that which tool is used for it. Okay, then these are external undercuts here in the second diagram. These are manufactured with the help of the core pins. Sorry, these are manufactured with the help of core pins. Okay, removable core pins. Then this undercut on the side wall, these are also manufactured with the help of core pins. And here, to make this circular undercut, here grooving operation is performed. Grooving operation is performed with the help of putting tool. And this undercut is obtained. So these are four different types of the undercuts. Okay. Now, after understanding the different types of the undercuts, we will move towards the inserts in the plastic part. Okay. Now, first I will show you these are the different types of the inserts. Okay. Now it is visible on your screen. These are different types of the inserts which we are going to use in the plastic parts. Now, as far as plastic parts are concerned, whichever inserts are used, we are using metal inserts only. Okay, it may be made up of, generally we are using the inserts, we using the brass material. Then you can go for aluminum, steel, or other ceramics also. Okay, generally these aluminum in metal inserts are sorry, brass metal inserts are used in the plastic parts. You can see these are different types of the inserts which can be used for the plastic parts. Now, what is the purpose of using the inserts in the plastic part? Okay, in the plastic parts, and to take care of the whichever wear and tear is occurring, these inserts are used. Okay, this is the main purpose of providing these inserts to take care of the wear and tear occurring. And if suppose some load is acting on the plastic part, and that load is beyond the capacity of the plastic part, then it may get failed. To avoid this, to carry that mechanical stress, to carry the extra mechanical stress in this metal inserts are used. Okay. Main purpose is to take care of the wear and tear occurring and to provide or to carry the mechanical stress. Okay, that is beyond the limit of the plastic material. Okay, that is the main purpose of the using these inserts. Now these inserts are also used to decorate the part. Okay, it will provide some make the part attractive. Then sometimes these inserts can be used to transmit the electric current, or these inserts will help. Okay, these inserts by providing the internal threading, you can say that these inserts can be useful for sub assembly or assembly work also. Okay, these are the inserts. Okay, by providing the threading, okay, internal threading, you can say that it can be used for making sub assembly and assembly work. So this is the purpose of this insert. Now, after describing this purpose of using these inserts, which material can be used for making these inserts? Different materials are used. You can now, as far as the inserts in plastic parts are concerned, we are using different metals. Okay? Different metals are used. Metal inserts are used, and in that specifically, generally we are using brass material. Sometimes aluminium, steel material is also used, or ceramic material is also used. But means, generally we are using brass. Okay, lots of times or many of times brass is preferred for manufacturing that insert. Okay. Now, knurling is provided on the insert. Okay, these are inserts. You can see on this top surface, knurling is provided. Okay, knurling is provided. Why this knurling is provided? So that it will provide the adequate holding support. This knurling is provided here. Okay, this is the knurling. Okay, this is your insert. Yeah, it consists of some internal threading so that it can be useful for sub assembly or assembly work. It will be then some knurling will be there on the surface, top surface, for holding support. Okay. Then there are two types of this inserts: molded in inserts and post molded inserts. Okay, these are two types of the inserts: molded in inserts and post molded inserts. Okay, now molded in inserts are placed in the mold itself before closing it. Okay, what is the difference between molded in insert and post molded inserts? Before closing the mold, that insert is placed inside the mold, that is molded in insert, and after closing the mold, we are attaching the insert or placing the insert, that will be termed as post molded insert. Okay, post molded inserts means that insert is installed after the molding process. Okay, the insert is installed before the molding process, and it is placed inside the mold and then it is closed. And the mold insert which is installed after the molding process, it is termed as the post molded insert. Okay, molded in insert and post molded insert, depending on when it is installed. This first one, molded in insert, it is installed in the mold itself before closing that mold. That's why it is termed as molded insert. And the insert which is installed after the that mold closes, that's why it is termed as post molded insert. Or after completion of that molding process, it is inserted or it is installed. That's why it is termed as post molded. Okay, post molded means after completing this or closing the mold or completing the molding, this insert is installed. That's why it is termed as post molded. Okay. Molded in and post molded inserts, these are two types. Okay. So these are different types of the inserts used. Generally, we are using brass inserts. Here you can see clearly on this surface, knurling is provided on this top surface. Knurling is provided here. Knurling is provided so that it will provide the adequate support for holding, and internal threading is provided here. Internal threading so that it can be helpful for assembly or sub-assembly work. Okay. Okay. Here, this is the how it is fitted. Okay. Inside the boss. Okay. Threaded insert inside that boss. It is fitted. Okay. Internal thread, and here knurling is there. With help of that, it is fitted in this boss, and it will this internal threading will help to use the screw to join the other parts. Okay, so this is the metal insert used in the plastic part. Let's draw this diagram. Okay, now as far as some design or dimension related guidelines are there. Now here, when generally this as this diagram indicates, this inserts are fitted in this box. Now, related to its dimensions, means its diameter of this insert, and you can say the depth or height of this insert is concerned. So now, suppose whenever this diameter, okay, diameter of this, you can say that diameter of the insert is less than 6 millimeter. Okay, if diameter is less than 6 millimeter, then you have to use a boss having twice the diameter of this insert. Okay, if outer diameter of the insert is less than 6 millimeter, then diameter of boss should be twice of this insert's diameter. Okay, this is the first design related guidelines. If diameter of this insert is less than 6 millimeter, then diameter of boss should be twice the diameter of this insert. And if diameter is of this insert is more than 6 millimeter, okay, more than 6 millimeter, then here whichever wall thickness is there, okay, whichever wall thickness is there, then diameter of a box should be 50 to 100% of that wall thickness. If this diameter of insert is more than 6 millimeter, then diameter of box you have to take into consideration the wall thickness, and you have to take 50 to 100% of the that wall thickness, and you have to decide the boss diameter. Okay, in this way diameter is decided, and as far as depth is concerned, depth or length is concerned, whichever diameter is there, depth should be twice the diameter. So these are the design related guidelines. Okay, I will repeat this. When diameter of the insert, this outer diameter is less than 6 millimeter, then boss diameter should be two times the insert diameter. And if this diameter of the insert is more than 6 millimeter, then diameter of boss is 50 to 100% of wall thickness. And related to its depth, in any case, whatever is the diameter of the insert, its length should be two times the diameter. Its length should be two times the diameter. These design related guidelines you have to follow while designing this metal insert and you are fitting it in the box. Okay, with the help of that, you have to design the box to fit this, to use the metal inside. Okay, so in this way we have discussed this undercuts, then inserts, and after this we will move towards the next part, that is the mold material. Okay. Okay. Generally, now whenever you are selecting the mold material, you have to take into consideration the 3 points you have to take into consideration. Okay, whenever you are means for conducting any molding process, mold is required, and we are generally using the steel. Okay, you can say that generally steel is used, and you can go for different types of these steels. These are general considerations. I will explain first general parameters and general materials used, and after that we will discuss the materials according to, means material used for making the molds used in the for processing of the plastics. Okay, different types are there. According to that different types, we will discuss the materials. Okay, now whenever you are selecting the material to manufacture a mold, 3 points you have to take into consideration. That is life of the mold. Okay, life of the mold means how much mm, that particular quantity of the product can be manufactured with the help of that single mold. Okay, that will be considered as a mold life. Then finishing of the plastic part. Okay, whichever mold you are using, depending on that mold only, you will get the final finishing of the product. So that you have to take this point into consideration. Then raw material. Okay, depending on the raw material only, that suppose if you are using the, there are two types of the raw materials, means sometimes your plastic material will be soft in nature, or sometimes it will be hard in nature. Okay, now if your plastic material is soft, then you have to go use the pre-hardened steels. Okay, whenever soft plastic material is there, these pre-hardened steels are used, and whenever material is hard, then tempered steel is used. Okay, then as far as your mold life is concerned, if suppose you want more life of that mold, then tempered steel is used. And suppose for lesser life, okay, suppose lesser life means some you can manufacture less than 2 lakh components from that mold, then you can go for this pre-hardened steel or forged steel. Okay, so in this way, these three factors, that is the mold life, finishing, and plastic means which a type of the raw material, whether it is a soft raw material or hard raw material, depending on that you can use different types of the steels. Okay, generally for making the molds used in the plastic molding processes, these three types of steels are used: forged steel, pre-hardened steel, and tempered steel. Okay, now suppose out of these three steels, this tempered steel will give you more mold life, and this can be used for hard plastic materials also. Then this pre-hardened steel and forged steel, these two types of steels are used for soft material, and their mold life is little less as compared to the tempered steel. And suppose if you want more finished products, okay, fine finished products, then you have to go for chromium steel, nickel steel, or stainless steel die, that mold. Okay, mold will can be manufactured with the help of chrome steel, nickel steel, or stainless steel. to get the better surface finish. Okay, so these 3 points you have to take into consideration, and generally these three types of steels are used, and they will give you a different mold life. You can say that from as you move from this one to three, this third one is having mm, higher mold life. Then you can say that better surface finish, and it can use or process the hard plastic material also. And for this number one, forged steel and free hardened steel, mold life is less and surface finish is also a little bit poor. And here you have to use the soft plastic material. Okay, so this is the factors you have to take into consideration while selecting the mold material. And generally for making the mold plastic, for mold for plastic materials, these three types of the steels are used. Now we will discuss related to process by process which mold material is used for injection molding. Okay, I have made one chart here for injection molding. Generally we are using steel and aluminum material. And for compression and transfer molding, here also steel and aluminum material is used. And for rotational molding, aluminum, steel, and copper nickel alloys are used. Okay, steel is common for all molding processes. You can use the steel material for manufacturing the mold, and for some specific molding processes, other materials can also be used, like injection molding, compression and transfer molding. You can use steel and aluminum. In the rotational molding, steel, aluminum, and copper nickel alloys are used to make the mold. And for blow molding, you can use steel, aluminum, then brass and beryllium bronze. Okay, for blow molding, these steel, aluminum, brass, and beryllium bronzes can be used to make the mold. And as far as the extrusion molding is concerned, only steel is used for making the required mold. Okay. Only steel is used as a mold material. Okay. In this way, for different plastic processing methods or molding methods, these materials like steel, aluminum, and copper nickel alloy, then bronzes, then beryllium bronzes can be used depending on the type of the molding process. Different mold materials can be used. Okay. So this part is finished here, mold material. So in this way, we have completed this chapter. Now I will take the review related to this. Okay. Okay, these are some MCQ questions. Uh, some 10 to 12 MCQ questions are there. Within 10 minutes, 5 minutes, I will uh, take this. Okay, materials having, uh, you can say that means you have to put here low, medium, and high shrinkage allowance can be molded with close tolerances. Okay, which material can be molded with close tolerances? Which materials? Means materials having low shrinkage allowance, high shrinkage allowance, or medium shrinkage allowance. And to get the close dimensional accuracy, shrinkage allowance should be low. The answer is A, low. Then now, due to the nature of the plastic, okay, after the completion of the molding process, when we obtain the final product, then its dimensions are, what will be changing the dimensions, whether it increases or dimensions will be smaller or dimensions will be bigger. Okay, so here we will get the smaller dimensions whichever cavity we are using, as compared to that cavity, due to the shrinkage of that shrinkage nature, we will get the smaller dimensions than as compared to the cavity usually. Okay, then minimum radius has to be provided in any situation while designing the corners. Okay, minimum radius. Okay, its answer is zero point 0.5 millimeter. Minimum radius 0.5 millimeter you have to provide. Okay, then this I muted it. I will repeat it. I think my voice is not visible. I will repeat all the answers. The material having means to get the close dimensional tolerances, material should have low shrinkage allowance. Okay, then due to the shrinkage of the plastic materials, we will end up with getting the smaller dimensions as compared to the cavity. Then minimum radius in any condition it should be 0.5 millimeter. Then the draft on polyethylene material it is 1 by 8 degree. For nylon material it is also 0 to 1 by 8. Then for rib thickness, to decide the rib thickness, you have to take into consideration wall thickness. 60 to 80% of the wall thickness. Okay. Then to allow sufficient pure time to cool the part before removing it from the mold, preferably to about 130 Fahrenheit. Okay. Its answer is B. And then in the designing of the plastic part, most important design aspect is wall thickness. Deciding the wall thickness is the most important aspect here. Now, the inserts are generally made of metal materials as far as your plastic parts are concerned. Then outer corner radius should be 1.5 times. Okay, 1.5 times the wall thickness. And if here uh, internal or inside corner radius they have provided, it should be zero point 0.5 times. Okay, then the ratio of volume of the loose plastic powder to the volume of molding. It is known as bulk factor. The answer is C. Then the gating system is usually provided in the fixed half of the mold. Fixed half or stationary half. Okay. Stationary means fixed half of the mold. In this way, we have concluded this part. Okay. In this way, we have discussed the MCQ questions. With reference to these MCQ questions, you can answer that whichever the MCQ tests are there. I have answered the questions from this only. Little modifications may be there. You can solve it. Okay. Now, after completing this, in this way, we have finished this chapter. Okay. Now, I will just take a summary what we have studied in this chapter. Okay. So in this design of a plastic part, within few minutes, so we have studied these prerequisites, then title, central idea of the chapter. Okay, first we have started with the in the design of the plastic parts, which factors we have to take into considerations. That we have considered different factors like material considerations, and then radius, wall thickness, gate location, drafts, then ribs, mold shrinkage, and some special features. Okay. Now, after this, we have studied the concept of tolerances and allowances in the plastic part. Tolerances of plastic parts, allowances in the minimum wall thickness. Okay, minimum wall thickness, and how to then design related guidelines for choosing the minimum wall thickness. This is most important aspect in the plastic part design. Okay, these are different wall thickness considerations. And after this, we have studied the tolerances, different types of tolerances in plastic parts, different types of allowances in the plastic parts. Okay, then we have studied the coring in the plastic parts. Okay, design of the coring, design of the ribs, and design of bosses, and design of the cassettes, and design of radius, fillets, you can say that, or corners, how to modify the design, then draft or taper, and holes or openings in the plastic parts, different types of the holes and their design related guidelines. Then undercuts, different types of the undercuts, then inserts, different types of the inserts. And we have studied the mold material used. Then we have also which slide which I have not added here. That part also we have studied. That is the what is the meaning of the curing time. Okay, curing time. That is and that also we have studied. Then the mold materials according to the different types of the molding processes. And after this we have this is the summary of this design of the plastic part chapter, and we have also completed the MCQ questions. Okay. So in this way we have completed the first section, and for all four chapters are finished. And I have shared the MCQ test, fourth MCQ test, one day before. Please attempt it. I have extended its timeline, and please solve it till today's evening, maximum tomorrow morning. Please solve it. I have increased the attempts also. If you have not able to understand, means able to answer all questions, please reattempt it. I have increased one more attempt. You can attempt it. Okay. So I will provide means share this presentation for your reference. Okay, thank you for attending this session. Now I will stop here. Thank you very much. Those who have joined late, please put your roll number in the chat box. If you are not mentioning your roll number in the chat box during the whenever I am asking, then I am not putting your presentee. Okay, I am getting one summary sheet of these chats where I can collect your roll numbers. Okay, it may get reflected in your attendance. Okay, so from next session, we will start the second section, and the fifth chapter we will start. So attend that session. Tomorrow, I will take the second practical. Okay, design of the plastic bottle cap. Okay, by using the for that we are going to design one mold design using the injection molding process that we will conduct in the next session. Second practical I will conduct tomorrow. Please attend that session, and thank you for attending this session. Okay, I will stop here. If you are having any query, you can put that queries in the chat box.